Hello, statistics students, Mr. Pizzato. This is a video solution to the counting problems that you were working on for review for the assessment. So in problem number 1, you could see the work, but I'm going to explain every problem. A soccer player takes 2 penalty kicks, so that's why I drew 2 dashes. And each attempt can result in a goal or a miss. So for each kick, there are 2 choices, so 2 times 2 gives the final answer of 4. For problem number 2, and you can obviously fast forward this video to look at any solution you need. So for problem number 2, an ice cream stand offers single scoop waffle cones or bowls, and then there are 4 flavors. So in order to solve this problem, you had 2 choices for the type of waffle, cone, or bowl, and then you had 4 choices for the different flavors, so 2 times 4 gives you the final answer of 8. Again, feel free to fast forward to the problem that you need help on. For problem number 3, a batter bats 4 times, so I drew 4 dashes. And at each bat, there are 3 options. You can get an out, get on base, or hit a home run. So I did 3 times 3 times 3 times 3 for a final answer of 81. Problem 4 was a little different, and we didn't do a problem like that in class. So you have a choice of a sedan or a hatchback. So that's that 2 choices that I just highlighted in blue. It is available in seven different colors, so that's why there is the 7 there. And the second part, or the last part of this problem, was a little different. You can choose any of the 5 additional options. So I drew 5 dashes for the different options. And for each option, I could either choose to get that option or not. So that's why there's a 2 there. So for option 1, let's suppose I wanted, for instance, upgraded tires. I had 2 choices, upgrade the tires or not upgrade the tires. For option 2, suppose I wanted power windows or not. For option 3, it could be 4-wheel drive or not. For option 4, maybe I had a rear view camera or I didn't have a rear view camera. And then for option 5, suppose there were side mirror cameras or not. So that gives a total of 448 choices. Continuing on, problem 5 is similar to problem number 4. So if you look at that particular problem, for a sandwich, you had 3 choices for the meats. You had 2 different choices of bread, so that's the 2. And then for the toppings, you had 7 different toppings. So for instance, pickles, you can get pickles or not, so that's why there's that 2. Ketchup, you can get ketchup or not get ketchup, that's why there's the second 2. Mustard, you can get mustard or not get mustard, that's why there's the pink 2. And there were 7 different options, that's why I have 2 listed 7 times. So when you multiply those together, you get 768. For problem number 3, you are putting 5 books on a shelf. So you could do it using the dash method, 5 choices, 4 choices, 3 choices, 2 choices, and 1 choice, and you would multiply them. Some people in class did 5 factorial, and there were even some people in class that liked 5 permute 5. So there were 3 ways of doing problem 6. The next couple problems talk about identifying whether it is a combination or a permutation. So if you look at the answers in number 7, you have 8 different people that are getting on the elevator. It doesn't really matter what order they are in, so number 7 is a combination. For problem number 8, if I'm vice president and you are president, that is different if we switch positions, so permutation is important. For problem number 9, you're just selecting 2 representatives. Me and you are the representatives. Order is no longer important. So for number 9, it is a combination. And for problem number 10, it says he's deciding the order to complete the homework. Clearly, you're going to complete stats homework first, then your English, then science, then social studies, and then your business. So order is important. And just for clarity, you may do that in a different order. Maybe you're going to do the business first, and then science, and then social studies, then English, then your statistics. So the order is important in this particular problem because it's deciding the order. The next couple questions, I'm going to show you the solutions and we're going to look through them. Number 11, it's a permutation. You care about who gets the gold, silver, and bronze. If US gets the gold and Canada gets the silver, that's different if Canada gets the gold and US gets the silver. So this is a permutation. So this is what you would type in your calculator and your final answer. For number 12, if I'm the captain and you're the co-captain, that's different if you're the captain and I am the co-captain. So some people did 15 permute 2. Other people might do 2 dashes. You have 15 choices for captain, then 14 choices for co-captain. Either way, you get 210 for your final answer. For problem 13, again, it says order is important there. So you're lining up, you're doing your 7 different homework assignments. So you could do 7 times 6 times 5 times 4 times 3 times 2 times 1. Some people realize that that is the same as 7 factorial. And I know there are some students in class that like 7 permute 7. All 4 answers, or all 3 ways get you 50-40. In number 14, 15 applicants for different positions. So if someone's the programmer versus the software tester versus the manager versus the systems engineer, that's different. So if I get the software tester and you're the computer programmer, that's different if I'm the computer programmer and you're the software tester. So this is a permutation, 15 permute 4. Other people like to do the dash method, so they do 15, 14, 13, 12. Either method gives you the same answer. Continuing on, we look at this group of problems, 15 through 18. The order is not important. So number 15, you're just picking 4 representatives. Doesn't matter the order. So if it was Taylor, Wills, Rick, and Max, that's the same 4 representatives. If it was Wills, Max, Taylor, and Rick, so it's a combination. Doesn't matter what order you do that one. Number 16, you're just looking for the top 7 people. They advance. Order is not important. So that's 735, choose 7. For number 17, you're looking for just 4 computer programmer positions. That's a little different than problem number 14. So if you want to compare and contrast number 14 and 17, notice 14 has the listed positions. In contrast, 17 does not. So 17 is a combination, 35, choose 4. And then the last problem, Gabriella only has time to do 5 of the 7. It doesn't say the order that she's referencing. So out of the 7 assignments, you can choose any 5, and that's 21 on the calculator. The next 4 problems you needed to decide. Again, actually in all of these problems you needed to decide. But I'm hoping that you could look at this group of problems, 11 to 14, and realize they're all permutations. 15 to 18 are all combinations. And the next couple of problems, I kind of scrambled the order a little bit. So if you look at number 19, it doesn't matter the order. You're just choosing 3 players, so 14, choose 3. In number 20, it does matter. If you go 1 week to Florida and then a 2-day vacation to St. Louis and a 2-week vacation to Hawaii, and then a month vacation to California, that would be different if you switched the order and you went on a 1-week trip to St. Louis, a 2-day trip to Hawaii, a 2-week trip to California, and then a month trip to that other destination I had mentioned. So order does matter. So 14 permutes 4. And Number 21 and 22, I'm going to start on number 22. So number 22, 180 politicians shake hands. There are 2 people that shake hands at a given time. So it would be 180 choose 2. We did that problem one of the days in class, so it's been a while since we looked at that one. For problem number 21, the author said there were 32 people and they will go in groups of 8. So the author said the answer was 32 choose 8. However, I disagree with this problem, and I put a little note here. Because it says the second trip, the way I interpreted this problem, and I think the answer key is wrong for the person who wrote this answer key, since 8 took the elevator on the first trip, I believe that there are only 24 people left. So me personally, I would have done 24 choose 8 to get this answer that I highlighted in pink. So I disagree with the answer key. I wanted to show you that sometimes people that create answers may not create the correct answer. So I personally believe the correct answer is 735,471. So if you got that answer, I would have agreed with you and given you full credit. So I hope you found this video helpful on counting problems.